Hello children, welcome to my chemistry class. I am Javashri Ghosh, teacher, Demonstration Multipurpose School, Bhubaneswar. Children, I am really very happy to have you all once again. I think you too feel the same. We just don't know each other, but we feel so connected, is not it? Children, get ready with your science book, notebooks and pen. We shall study some other new concepts of chapter number 3. Let's start. Today we'll be discussing molecules and writing the chemical formula. But children, before discussing these topics, let us brush up what we had done in our last class. I think you remember and you have gone through NCERT books and taken down the notes. I know you all are good children, you'll be doing that. But let's have a recap. We had done atom. An atom is the smallest unit of matter that has the characteristic property of a chemical element. I had explained you all. Then comes symbols of atoms and elements. Element symbols for chemical elements normally consist of 1 or 2 letters from the Latin alphabet and are written in the first letter in capital. You remember that H for hydrogen, He for helium, C for carbon, Cl for chlorine, and it goes on. Now, atomic mass unit. We had done that. A unit of mass used to express atomic and molecular weights equal to 1/12 of the mass of an atom of carbon C12. You remember, we had taken the example of a watermelon. We have cut into 12 pieces. Okay, that one. Now, children, we'll learn about molecules. We have learnt about molecules. Just a recapitulation. It is the smallest particle of an element or a compound which is capable of independent existence. I told you, they are capable of independent existence. It shows all the properties of that compound or the element. It is a group of 2 or more atoms which are chemically bonded. Atoms of the same element or different elements join together to form a molecule. Children, let me talk about molecules now. Suppose we take oxygen atom. Oxygen atom, hydrogen atom, you say chlorine atom, they feel quite unstable when they are all alone. Okay. They want their brothers, sisters, neighbors to hold their hands, They cannot exist independently. So, they take the help of others. They bond with some other elements to exist independently. But children, there are some more elements like helium, neon, argon, krypton. All these are inert gases. They are noble elements. They feel so noble. They don't want to mix with anybody. They are comfortable in their own position singly. So children, these do not form any molecules like other metals and non-metals. Okay. Now, suppose we are talking about molecules of oxygen. O2 is the molecule of oxygen. That means oxygen in the form O2 is stable. Hydrogen in its form H2 is stable. Chlorine in the form Cl2 is stable. Okay. The number of atoms present in a molecule is an element or a compound is known as its atomicity. Okay, children. Suppose example is argon. Argon is a noble gas. It exists independently. Doesn't want any brother, sister or neighbors to hold his hand. Okay. So, argon is monoatomic. It contains only one atom. Oxygen, O2, it's diatomic because it contains 2 atoms. To be in stable form, it contains 2 atoms. One more form of oxygen is ozone, O3. It is triatomic. Okay, 3 atoms of oxygen are used. Phosphorus, P4, tetraatomic. Okay, phosphorus P4 is a molecule of phosphorus. That is, P4 is the stable form of phosphorus. Similarly, S8, 8 atoms of sulfur constitute the molecule of a sulfur, and it's stable in this form. Okay, and they also determine the atomicity of the element or a compound. Now, molecules of elements. As we had discussed, children, the molecules of elements contain same type of atoms. Molecules of many elements are made up of one atom of the element. For example, as I have told you, inert gases like helium, neon, argon, krypton, xenon and all those things. Because they are noble, they don't want to mix with anybody. Okay, like others, molecules of most nonmetals are made up of 2 or more atoms. Example, oxygen, O2, ozone, O3, chlorine, Cl2, nitrogen, N2. These are in gaseous forms. The number of atoms constituting a molecule is known as its atomicity. Okay, let's see what's that. See in the figure, children. 2 atoms of oxygen combine to form one molecule of oxygen, O2. In the picture on the screen, you can see, children, 2 atoms of oxygen. They have combined to form an oxygen molecule. Okay, children. Now see, 3 atoms of oxygen combine to form one molecule of ozone. You can see the 3 atoms of oxygen. They have combined to form ozone. Similarly, 4 atoms of phosphorus combine to form one molecule of phosphorus, P4, and 8 atoms of sulfur combine to form one molecule of sulfur. You can see how the form is just like the crown of a queen. It's not it? Children, we have discussed the molecules of elements. They contain single elements, but many 2 or more elements can also combine and form molecules. And these are the molecules of compounds. Molecules, atoms of different elements join together in definite proportions of their masses to form molecules of compounds. Children, indefinite proportion of their masses means, you remember, we had discussed about water, hydrogen and oxygen are in the ratio 1:8 by mass to form water. Similarly, in ammonia, N and H combined by the ratio 14:3 by mass to form ammonia, NH3. N is 14. And for this, children, let me tell you once more, you have to remember the atomic masses. Okay, so make a list of it and go through it when you get time. N is 14, atomic mass of nitrogen is 14 and that of hydrogen is 1U. And here we are considering 3 atoms of hydrogen, NH3. So they are in the ratio 14:3 by mass. Okay. Diatomic molecules. Di means 2, HCl, 1 atom of H and 1 atom of Cl. They form hydrogen chloride and they are diatomic. Similarly, carbon monoxide, nitrogen oxide, then comes sodium chloride. 1 atom of sodium and 1 atom of chlorine. Similarly, children, let's go for the example. Triatomic molecules. CO2, 1 atom of carbon and 2 atoms of oxygen, they form triatomic molecule of carbon dioxide, nitrogen dioxide and water. Okay? You can find many other examples also from your book. If you know certain compounds also, you can tell whether they are diatomic, triatomic, tetraatomic or polyatomic. Tetraatomic, 4 atoms, H2O2, hydrogen peroxide. We call it hydrogen peroxide. 2 atoms of hydrogen and 2 atoms of oxygen. They form H2O2. What about NH3? That is ammonia. 1 atom of nitrogen when combines with 3 atoms of hydrogen, they form NH3. AlCl3, aluminium chloride. It is also tetraatomic. Poly means more than this. We can't just go on saying penta, hexa, hepta, octa. We call it polyatomic. For example, glucose. What is glucose? C6H12O6. Methane, CH4. Nitric acid, HNO3. Sulfuric acid, H2SO4. So, all these are polyatomic molecules. Children, now you might have got some idea what are diatomic, triatomic, tetraatomic, polyatomic molecules of compounds as well as elements that we had discussed. See here, children, for molecules we have seen those pictures for elements. Now for molecules you have 2 atoms of hydrogen and 1 atom of oxygen. What do they form? Yes, they form water. You can see how they form water, the picture of water. Similarly, this one is CH4, methane. C in the middle and 4 H atoms. Then comes ammonia, NS3. See, nitrogen in the middle or in the center you can see nitrogen and 3 atoms of hydrogen. This is how they form the molecules. Okay? Look at the screen for a few seconds and you can remember this. Now children, let's go for ions. It's a very important part of this chapter, ions. The word ions is not new for you all children. We have discussed these words in class 8 also. Where? Do you remember? When you might have studied electrolysis of compounds in class 8, there we had come across the word ions. When electricity passes through ionic compounds in their molten state, what happens? Or in the solution, what happens? They dissociate or they form 2 types of ions, positive and negative. What are these ions? These are simply charged particles. Is not it? The molecules of the compounds composed of metals and non-metals contain charged species called ions. Okay, these are the charged particles. Ions can be positively or negatively charged particles. That you know. Now, positively charged particles are called cations and the negatively charged particles are known as anions. You might remember, children, the positively charged particles move in the process of electrolysis. The positively charged particles move towards the negative electrode, that is cathode. So, they are known as cations. The negatively charged particles, they move towards the positively charged electrode, that is anode, and those are known as anions. Compounds in their aqueous solution form charged entities or charged particles, you can say. NaCl, sodium chloride. In its molten state, of course, or in the solution with water, it dissociates into Na plus and Cl minus on electrolysis. Na plus is cation, Cl minus is anion. Na plus move towards the negative electrode, cathode, and Cl minus move towards the positive electrode, anode. Ions may consist of single charged atoms like Na plus and Cl minus. Okay. Ions can also be group of atoms that have a net charge on them like NH4 plus or SO4 2 minus. Till now, you have known that some like Ca plus plus or Cl minus or Na plus, Cl minus, these are cations and anions. These are elements. Okay. But there may be group of atoms also. Here you have sodium atom or chlorine atom. Is not it? But children, you can have also group of atoms which can make anions, group of atoms which can make cations. Okay? NH4 plus, nitrogen and hydrogen combinedly form NH4 as cation. SO4 2 minus. These are anions. Certain group of atoms, and you can have some other examples also. For example, children, these are ionic compounds because these compounds on dissociation they form ions. Okay. Calcium oxide. What is the formula for calcium oxide? It's written there CaO. And one more thing. Children, do you remember the atomic masses? You have to remember it. Otherwise, it will be difficult for you to do the numericals. So, children, keep those ready with you. Calcium atomic weight is 40 unified mass. U means, remember, unified mass. Oxygen, it is 16 unified mass. What is the ratio by mass? 40 is to 16 is simply 5 is to 2. We divide it by 8. That you know, simple mathematics. Okay, children? Next, it is magnesium sulfide, MgS. Magnesium, try to recollect atomic mass, 24 unified mass. Sulfur, 32 unified mass. What is the ratio? 24 is to 32, and on simplifying we get 3 is to 4. Is not it? You can also side by side do on your notebooks. Then you can be confident about it. Okay? Keep writing. Sodium chloride, NaCl. Sodium is 23 units and chlorine is 35.5 unified mass. Then ratio by mass comes out to be 23 is to 35.5. This is the ratio. We can't simplify it further. Then comes sulfuric acid. Sulfuric acid, you have 3 atoms, 3 types of atoms. What are they? Hydrogen, sulfur and oxygen. Hydrogen, H2. 1 atom of hydrogen atomic mass is 1. So, 2 atoms of hydrogen will have 2 unified units. Sulfur, 32 unified mass. Then, oxygen, O4 is there. See children, O4. 1 atom of oxygen mass is 16. So, 4 atoms of oxygen will have 64 units or unified mass. What is the ratio by mass? 2 is to 32 is to 64. On simplifying, what do we get? 1 is to 16 is to 32. Divide by 2. Children, I hope something gets into your mind by seeing all these things. You can do it. It's very simple, children. Just you have to remember the atomic masses of certain elements. As in the last class, I have told you, minimum first 20 you have to remember. Okay? Children, let's learn writing chemical formula. Those formula of compounds we have discussed or you might have read somewhere, but how to write this formula? We have certain steps and I'll tell you how to write it very easily. Okay, children? Be ready with your pens and chemistry notebook. The chemical formula of a compound is a symbolic representation of its composition. Why do we have to write the chemical formula? We just can write 2 atoms of hydrogen reacts with 1 atom of oxygen, we get water. And instead of writing H2O, which one you find comfortable? Of course, we find the formula comfortable. Is not it? So, it's required to write the formula. Then comes a very new concept, that is valency. What is that valency? The combining power of an element is the valency. It can be used to find out how the atoms of an element will combine with the atoms of another element to form a compound. Children, I'm afraid, but let me tell you. In this chapter, you have to remember the valencies of certain elements. Remember means by heart or by practice. Because in the next chapter, you will come to know how to calculate the valencies. But in this chapter, you have to just remember and just wait for a few more days. You can know about valency. Okay? In the next chapter, you have in details. While writing chemical formula, the valencies of the ions must be charged Either they have positive valences or they have negative valences. Okay, children? In a chemical formula, cations are written first, followed by anions. Generally, metals are the cations and non-metals are the anions. First metals are written and then non-metals are written. First positive valences, then comes the negative valency. Okay. A simple way to denote formula are simply crisscross or swapping the valencies of the cations and anions. In case valencies are the same, the valencies cancel each other. What is that crisscross and what is that swapping? This is just the interchange of the valencies among the elements. Let's see how this happens and how we can write the chemical formula. Very easy, children. Before that, let us know which are the valencies of various elements. Some are monovalent, some are bivalent and some are trivalent. Monovalent means valency 1, bivalent means valency 2 and trivalent means valency 3. Monovalent. Let us go for the positive valencies. Sodium Na+, potassium K+, hydrogen H+, ammonium NH4+. Because we have discussed there are certain group of atoms also can have valencies. But negative valencies are hydride H-, chloride Cl-, fluoride F-, iodide I-, bromide Br-, nitrate NO-, hydroxide OH- as a whole. Then bivalent magnesium 2+, calcium 2+, zinc 2+. You can note it down, children, if you want. The screen is over here. You can note it down. Oxide 2-, sulfide S2-, sulfate, again group of atoms, SO4 2-, sulfite SO3 2-, carbonate CO3 2-. These are bivalent. What about trivalent? Trivalent are aluminium Al3+. Okay. Nitride N3-, phosphide P3-, and phosphate, it's a group of atoms, PO4 3-. Now children, get ready with your notebooks and pens to learn. Suppose you are supposed to write sodium chloride. In sodium chloride, elements involved are sodium with valency, yes, 1. Then comes chloride with valency -1. Then what happens? See here. Since +1 and -1, they cancel each other. So, what is the compound formed? Compound formed is NaCl without any valences to be written. Okay. Suppose we write potassium carbonate. Okay. Potassium K with valency +1. Carbonate CO3 with valency -2. Is not it? Then what happens? There is swapping or the crisscross. K will have valency 2 and CO3 as a whole will have valency 1. How do we write it? The formula becomes K2CO3. K2, and children, a question may arise in your mind that why not -2? But children, this plus and minus signs we are using just to denote whether they are anions or cations. Okay, you are not supposed to use this minus or plus sign while writing the formula. K on crisscross method or swapping the valencies, K has got 2, so 2 is to be written with K and 1 is to be written with CO3. Okay. Then comes magnesium chloride. Magnesium has valency +2. Chloride and valency -1. Then what happens? Swapping, crisscross. Mg will have 1 and Cl will have 2. See here. It will become Mg because Mg is taking the valency of Cl, that is 1. 1 means you are not supposed to write anything. 1, we don't write anything. Okay. Then comes Cl2. I hope children Something gets into your mind? If you see it carefully, you will be understanding very easily. Calcium phosphate. Calcium valency +2. Phosphate, you remember? PO4? Yes, it's 3 minus. Now the swapping is there. See here, calcium. Yes, guess. What will be the formula? Yes, Ca3 and PO4 whole twice. Why whole twice, children? Because this 2 is for PO4 as a whole. Okay. So, we put a bracket. Like in the previous case, CO3, since it is 1, we need not put any bracket. But here PO4, 2 is for full PO4, so we are putting a bracket. That means here, what is the atomicity of this calcium phosphate? 3 atoms of calcium. And how many atoms of phosphate are used here? 2 is for both. So, phosphate has 2 atoms and oxygen has 4 into 2, that is 8 atoms. Okay. Then atomicity becomes 3 plus 2, 5 plus 8. Okay. 13. Children, I've got some assignment for you all. As we have discussed, you can go home or you are at home, I know children, and you can do this. You can take down this assignment. Please note it down. Write down the formula for the following. Sodium oxide, aluminum chloride, sodium sulfide, magnesium hydroxide. Okay? The screen is open for you all. You can write it down. Question number 2. Write down the names of the compounds represented by the following formulae. Al2SO4 whole thrice, CaCl2, KNO3, MgCO3. Okay? Next question. What is difference between 2Cl and Cl2? Which of these two forms exist in nature? Let me give you a hint. 2Cl means 2 atoms of Cl and Cl2 means 1 molecule of Cl, and Cl2 is independent in nature. Write the atomicity of the following. You can do it. I2, H2S, HNO3, Na2SO4. That's very easy. An element of X forms X2CO3 whole thrice type of compound. Okay. What is the formula of his phosphates and chloride? Children, just think of it for 2 seconds. The element is X2CO3 whole thrice. Means, what is the valency of X? Try to remember the swapping. Yes, X has valency 3 and CO3 has valency 2, which has come to X, and 3 has gone to CO3. So, valency of X, element X is 3. What is the formula of phosphate and chloride? Phosphate, PO4. You can just interchange the valencies, 2 minus. And chloride, you know the valency 1 minus. You can interchange and you can find the formula for this. Okay. What are the cations and anions present in NH4NO3, NH4 plus, NO3 minus? And CaOH whole twice, Ca double plus or Ca2 plus, OH minus. Okay. So, you have to take down these questions, write the answers in your notebooks. Children, this is all for today. Promise me to write the answers of these questions, read the NCERT books and try to solve the questions in those books also. Stay home, stay safe children, take care with bit of studies. Thank you. It's all for today children. Bye.